So let's start, right? This is my second talk today. I'm still very excited to be here, but I had lunch, so I'm a bit more tired. Who has seen my first talk here? Oh, wow, okay. That was almost everyone. Okay, this is cool. The relation is not too hard, so it doesn't matter if you've seen it or not. This talk title actually was a test. So I wanted to see if this link-based titles also work for conference call pages. You know what? They work. That's why we're here. So actually this talk is just about the 12-factor thing, 12-factor manifesto. But I want to explain it in more detail, and I want to point out some special things, and we'll cover the whole manifesto later on. Who of you know 12-factor manifesto, 12-factor apps? One. That's great. So you will actually, I'm sorry you won't learn something, I guess, besides some entertaining jokes. So, most of you have seen my first talk, so if you feel I'm talking bullshit, just tweet me, but just the nice things. Okay. I'm doing web development for 10 years almost. So, in tech, this is an epoch, right? It's like forever. So I feel pretty old. That's why I want to talk about history. That's how do we start it? I for myself started with PHP. So back in that time, I used a tool which looked like this. Who of you is familiar with that? Great. It's amazing, right? What I love the most about this tool is that you get continuous deployment for free. So whenever I hit save, my PHP files were synced to the FTP server. How great is that? I mean, okay, there wasn't like tests involved, and when a colleague saved after me, we might have some, like, we didn't have really conflicts, but my changes were just gone. But this is just how we did it back in the days, right? So back then, if you were with Ruby for quite a while, actually it was around the same time where there was the first versions of Rails. I don't know how Rails development looked back at then, but I think it was at least, there were some crimes committed, right? Everyone like back in the days committed some crimes. And this is the thing I did quite often. In my first company, we did it like that. So whenever we had to manage dependencies, we used SVN submodules. And for us, it felt like a good thing. And actually, this is a true example because we called our shared code base common. That was so stupid because nobody actually felt responsible for it, but all the projects used it. So it's like the most important code was at least maintained. But I'm not sure if this is a problem with SVN submodules externals rather than of company structure. But this was just how we shared code back then. So how do we do it today? Today we do like this. So we just add some stuff into our gem file, do bundle, wait for all these logs to scroll through, and then it's magically there. I want to ask a question. Why do we do it like this? Have you ever think or thought why we handle our dependencies in this way? Is it just because we got told to do it like that? There are reasons. There are some good reasons. And the first reason which comes into my mind is that we have explicit dependencies. You saw this common example. I have no idea what is in this common thing. I have no idea what my project actually uses out of this shared library thing. And I have no idea what version is used. So we also get version pinning with the gem log file. This is pretty great. So we got a lot of examples. We got a lot of advantages out of that. But what we also get is commands which look like this. And on my first slide, it even was like bundle exec format run, bundle exec ready to be migrate. But then I looked at the format and figured out they are passing the environment. So this is how you have to do it. So bundle sets up your Ruby environment, putting all the gems in the load path, and format sets up your environment, your application environment. This is a good thing, but for me this always feels a bit like I'm typing all these commands over and over again, and I don't, it's not dry, it doesn't feel dry because I'm just typing it because I have to, but it's not, I want to express my my task, this thing I want to do. But still, with this we get explicit dependencies without leaking into the global system, and we have dependency management and isolation. I think especially dependency isolation is pretty important, because with dependency isolation we get a feature that our dependencies are not globally available. When I think back to my PHP days, there was a thing they call peer, which is a library or dependency management system which just places the gems into a global path, similar to gem without bundle, right? And then you actually got into real problems if you have multiple applications running on the same server, having the same dependencies but in different versions. It's like almost unsolvable. So it's good that we have that. So in Ruby we have for this gem and bundler, Python has pip and virtualenv, and even C has autoconf. So this is regarding how we manage dependencies. The next thing I want to talk about is starting new projects. So in Ruby, what most of us, I guess, are doing when they want to start something new is this. Right, it's new, whatever project name. Maybe you are also appending some flags because you, don't like mini tests or whatever. Well, this has just how we started Ruby. And with all this code generation, I feel like we got a lot of advantages. We get rid of a lot of boilerplate we don't have to type on our own. But we also get a lot of opinions. And we also get a lot of boilerplate, so a lot of bad stuff. So when I type this into my command line and then see what's the result, I found this in the config directory. So this is a plain, fresh, Rails new config directory. So in this just freshly generated config directory, there are 668 lines of code. For what? Why do I have almost 400 lines of code on a project I didn't even have touched? This is crazy. For example, other frameworks have 0, or even the PHP folks, they have 160 in this Symfony framework. I just checked it. So it seems they do better in this. We have a lot of configuration in here which makes sense. So we have all these initializers. So now we can talk about if the initializer really is configuration. Sometimes you see that initializers are misused for code that should only run once. Maybe it's just in the wrong directory, but it is okay that it exists there. Then we also have routes. I feel like this is the most appropriate file in this directory. So this is pure application config. Maybe the same applies to boot, application, that's all fine. Also maybe environment. But what I do not like is this directory. When I want to configure my environment, why should I do it in my code? I feel like we should configure the environment within the environment. This would make total sense. If I have differences in the environment my code is running in, it should be part of the environment. Or my application should be able to read the stuff out of the environment. Best example, secrets or database hosts, right? We often store it in there, and then we do even like different hosts. Then, we have a bigger team, so everyone gets their own environment because they have, different ports open. I even have seen teams where they use different database backends for development. This is crazy. So some use SQLite, some use Postgres. This doesn't end up pretty well. But the point is, if you want to configure your environment, do it in the environment. Do things like this. This is pretty easy. You get tons of tooling around, which helps you in setting up these things. Foreman, which I just showed you. .env, outer env. All this stuff is there to help you setting up your stuff. And if I can give you one advice, when you switch your application over to an environment-based configuration, fail fast. Because if you read an environment and it's just not set, it's actually nil. And you can pass nil around to quite some stack levels, so back and forth, and then it will fail at a completely weird thing. So it fails at a point where you do not expect your application to fail, just because it's nil, often because it tries to cast it to something. So do this fetch, and with fetch, you will fail at this point where this statement is written, and you really see which environment variable is not present. There's a blog post you will find in the slides later by Grouper. They describe how they switched their a few years old Rails project over to environment-based configuration. There are tons of really cool tips in there. Another little trick is, or thing you should be aware of, that true, like the bool true in environment is actually a string. So true is not true. I leave it like that. You know it. So most of you have been into my first talk, so I think I should not elaborate on this even more. But it's part of the story. So I had this example of the SQLite database my colleague implemented in our code base, right? So as you see, it's part of all my talks because it was so horrible, really. So all your state should be in so-called backing services. So in Rails, for example, the default config comes to SQLite, and SQLite here is your backing service. So it is not that complicated as it looked like. So my colleague implemented the SQLite thing. So we ended up with all the state, and the requests had to go to this particular server, and it was all really crappy, right? So state is a bottleneck. So what do we do with all the state? And what do we do to scale this state? Usually we do things like sharding. Right? So you start to sharding a database. So all odd user IDs go to database A, and all even user IDs go to database B. This adds a shitload of complexity, really. It's really hard to maintain it, and you still have this problem of state, and you just make it even worse. What I would rather do instead is, again, a stateless architecture and an architecture which is based on processes. So here I have an example of how a process-based architecture can look like. So on the x-axis you see the workload diversity, and the y-axis you see the scalability, or the scale-out. In this example we have a pretty simple web process here. But in a real-world application it has a bit more complexity, right? So we also have a worker process, and because we're getting a bit more traffic, we have two web dynos, and here we also have a process called clock, which you can think of mesos or something. So something which is triggering a particular thing at a particular interval. If I want to scale out, and my bottleneck is my web server, I will just add more web processes, but the rest can stay the same. I do not have to scale the clock, I do not have to scale the worker. And this also applies to the worker, obviously. So if I want to scale the workers, I can just add more workers. So scaling out via the process model makes scaling way easier. So this Oscar, you might know him, Oscar the Groot. And he's part of my talk, but why? He's part of my talk because I want to talk to you about trash. I want you to trash your processes. You should trash and restore your servers fast. In order to trash and restore your servers fast, you need resilient architecture and you need resilient processes. In order to have resilient processes, you would need processes which have a fast startup and a graceful shutdown. What does fast startup mean? Fast startup means that you do not start to install all your gem file declared dependencies on process startup. This takes forever in architecture serverland. So do it before. So you have a right up bootable process at hand. You still might want to do some cache warming if your application might get crashed if it starts cold cache. What does graceful shutdown mean? So graceful shutdown basically means if you have a web process serving web requests, the first thing you should do if you receive a SIG turn is stop accepting requests. Then let the process serve all these pending requests and then shut down. Same for workers. If you know it's a long-running job and you receive a SIG term, just give the job back and say, okay, I give it back and then shut down. If you know it's almost done, finish it and then shut down. This is called disposability. This will make your processes robust against sudden death and your architecture more resilient. If you are hosting your application in the cloud, this is an essential thing you and your application should have, or you should have implemented in your application. Next thing I want to talk about is logs. So this actually is a screenshot of the logs we gather in our team. We are using Papertrail to aggregate logs. But that's not the point. I want to tell you the one truth about log files. There is no log. Everything is an event stream. Let me explain this a bit. When I'm searching rubygems.org for all gems related to logging, I found 1,233 hits. So we're really, again, crashing our gem infrastructure, our gem hosts, and our application with the handling of log files. And when I say it's part of the gem stuff, it's totally bound to Ruby. So we cannot share this with Node, for example, or Go. The same applies for NPM. NPM has over 1,000 modules which handles logs, which is, from my point of view, total bullshit. Why should the application concern the routing and storing of log files? Just use stdout. Just use the Unix process model again. So if you have an error, just post this error to standard error. If you have debug info, just post it to stdout. And then your environment will take care of routing it and storing it. Maybe your environment decides to store it in the syslog. Then the environment will post or will pass your stdout and standard error into syslog. Maybe your environment decides that it has to go into Graylog. Then your environment will take care of sending it to Graylog. Same as for log rotation. Your environment should make this decision. This is not part of your application. A typical Rails app does this kind of well already. So it uses stdout for logging as long as you don't put in any more gems. Again, I want to talk about crash. When we are writing an application, we come to a point where we need some kind of admin functionality. So the product manager comes to us and says, oh, hey, Ole, I need CSV export. This happens quite often, right? Or I want to have a daily mail report. I want to have something special which just I will receive and not the user. Basically this. So what are we doing? We're doing admin interfaces, which is not a bad idea in general. But what we do is that we have this almost or often long-running CPU or latency or I/O heavy processes and tasks running in the same processes, the same web processes our customers run in. Think of the CSV export, right? So it would mean we have a lot of I/O in this process and it would block for quite a long time. And then we have two web processes, and one web process can handle one request at a time. So as long as our project manager is downloading this CSV file, we are cutting our performance in half. So again, we are generating waste. We are jamming the service. This is so bad. So whenever you have an admin process, just run it as a one-off process. Just boot up a new process, do the admin work in there. So when we're talking about admin interfaces and downloading CSV files, for example, just put it into a queue and then let worker do the heavy lifting and then send it by email or something. So you can decouple your users' requests from the admin stuff. This is important. So all this stuff is part, again, of this 12-factor app. The 12-factor app is described in the 12-factor manifesto. This is written by Adam Wiggins, and he's working for heroku. So in this manifesto, he describes how the perfect cloud-ready application looks like. And all this stuff I mentioned before is basically part of the 12-factor manifesto. But I want to go through each of these 12 facets now point by point, but really quick. So number one is code base. So we have one code base, tracking revision control with many deploys. What does it mean? Basically this image. So you're storing your code in Git or SVN or Bazaar or whatever stuff you have in mind. And then you can do many deploys. So you can deploy to production, staging, all the different development machines. You can go to some integration stuff. Maybe you have also deployments to, I don't know, your QA people, right? So, but it's all originated in the same code base. Two dependencies. We talked about that already in detail. So it's about explicit, declare, and isolate dependencies. 3 is about config. So you should really store your config in the environment. This is what the 12-factor app says. Store your config in the environment. I will not agree on 100% in here because Rails treat the routes as part of config. And I do not recommend store your routes in the environment. This doesn't make any sense. But if you have environment-based configuration, store it in the environment. So when you configure your environment, store it in the environment. Secrets is another great example. Don't store your secret. Don't commit your secrets, right? What is the secret, YAML? What a bullshit. Just store it in the environment. All fixed. Backing services. Again, we tried to cover it. So the 12-factor manifesto says treat backing services as attached resources so that your application can be stateless. And all the state should be in this attached resources. An attached resource can be a database. Attached resource can be another service. It could be an API. It could be another internal service offering an API. It could be whatever. It's about that your application, your deploy, is stateless. Point 5, build, release, and run. So you should strictly separate build and run stages. Again, I got a little infographic because I always find it kind of hard to understand. So here you see the code base again. And your continuous integration server then creates a build out of your code base. Way too often, I see that people are downloading dependencies on the production system. So imagine you're deploying to 300 servers, and then 300 servers are installing dependencies. Why? They're installing all the same, hopefully. You would be pretty fucked if not. So there is no good reason to do not have this build step. Install all the dependencies, make a package out of it, and then ship it. So if you have your build built by your continuous integration system, then you would combine the environment config to it, and then you have an actual release. I always think that this picture absolutely looks like the Docker workflow, right? So Docker really is really much compliant to the 12-factor app. Number 6, processes. Execute apps as one or more stateless processes. So we also talked about that one. Number 7 is port binding. So you should export services via port binding. This means that there should no direct reads of data, for example. I have seen applications which rely on a communication on the file system. So one application is like just saving a file to a particular point in the file system, and another application picks it up. This is not the point. Always use network communication and have one defined port. Number 8 is concurrency. We also talked about that. You saw this image before. One process is a really small self-contained thing, but you can have multiple, and they should be really relevant. Number 9, disposability. Disposability means maximize robustness with sparse startup and graceful shutdown. Number 10, dev prod parity. So the 12-factor app says, keep development, staging, and production as similar as possible. The 12-factor developer resists the urge to use different backend services between development and production. This is for me the most trickiest point. Think of the default setup of Rails. You install Rails and you get SQLite database in the default, which is not a totally bad thing, but all the documentation says, okay, before you go live, remember switch the database. So you would not go to production with SQLite, right? But then, often we stick to SQLite in development because it's so easy, and then have a different database in production. And 12-factor app says that this is a bad thing. And I don't know if you already made this experience, but I would totally agree. Because the syntax is different. So if you're writing actual, like, handwritten queries and do not rely on the given abstraction, this won't work anymore. But this point gets a little bit tricky if we are talking about software as a service or platform as a service solutions. Who of you uses S3 to store files? Yeah, that's almost half the audience. I do the same for my applications. But how do I do this? Like, how do I follow this dev prod parity when I'm using S3? So the only thing I can do is like using S3 from my local machine. So I have an extra bucket, which is the development bucket, or even I have my own bucket, because as developer Ole, I might have other developers, so every developer has their own buckets. And then you're working with this bucket on actual S3. But I want to have my development environment locally. I do not want my development environment to communicate with the outside world. You hear this point pretty often, and most often the argument behind this point is, yeah, I want to be able to develop in the plane. Like, have you ever tried to develop in a plane? It's like this. It's completely shitty. It doesn't make any sense. So my reason that I want to have it all local is not that I want to develop in a plane. It's more, I want to have I want to know what's going on. I want to have the overhand of my system. So when I know it's all running on my laptop, I know that I have some kind of influence. We now can start to argue how much influence I have over a running Postgres server, but it's still all on my machine. What use case I do see for all local is when I'm in the train from Hamburg to Berlin, which is actually the only place in Germany where there's no cellular internet, there I could need this as well. But I hate this, I want to develop in a plane argument. This is just bullshit. So number 11 is logs. So treat logs as event stream. A 12-factor app never concerns itself with routing or storage of its output stream. And number 12 is the admin processes. So run admin processes and tasks as one-off process. So you would not block the actual user resources. So all of this is part of the 12-factor manifesto. And even if you got a good feeling on what a 12-factor manifesto means and what it describes, I really, really, really want to ask you to read it. That's URL. Most of the points hopefully will sound familiar because I tried to tell you, but he explained it very well, and I think he did a really good job in writing all this stuff down and giving lots of good examples. And it isn't too long, so it took me, I'm a really slow reader, but it took me like 2 to 3 hours to read the complete manifesto. And there's even like every kind of format is around. So they have all this ebook format, PDF, it's a web page, so there are tons of ways how you could consume it. So that's it. You know me already, right? So my name is Ole Michaelis. I'm working at Jimdo. You can tweet me, co-stars, my blog, my GitHub, my pet project. That's it. Thank you very much. I don't know, so the other room is running already. Does any one of you have the feeling he has a good question which would be interesting for everyone? Good. I like to elaborate on this point. So whenever there's Q&A, it's interesting for two people. The one who's asking and me, because I've never seen this perspective. I am totally open for any kind of discussion, especially the dev prod party. Please come and find me and talk to me about the stuff I'm telling here. I don't want to be closed, but I don't want to borrow 99% of the audience with one people asking questions. Yeah? So you're going to go, half an hour break. That's it.